Hello everyone, welcome to this lesson. So in this lesson, we're going to go through another variation of the polynomial regression Python code. I want to show you a simple way to actually optimize the existing code that we have created in the previous lesson to take advantage of Python's inbuilt functions. Now, if you remember, with polynomial regression, we built the code where we input the values, create the matrix and vectors. We undergo the creation of matrix A and B. Then after that, we did Gauss elimination, and after Gauss elimination we got the R squared, and we practically displayed the solutions. Now in this lesson I want to show you that actually within Python you can actually do Gauss elimination or solving systems of equation within Python just by one line of code, so by just calling a function within Python. So this is basically what I want to introduce to you in this lesson. So here you can see that we already have the importing of the xy definition of n, and also here we're going to be starting with a second order. Here are the matrix and arrays. Here is the creation of matrix A and B. So the only difference is here, this line here. So in here we actually created S using the backward substitution and forward elimination, but in this case we're just going to call the function or the keyword from the Numpy, so np.lin, which stands for linear, alg, which stands for algebra, so .ln alg.solve, and we're going to pass, the first term is going to be the matrix A, and B is going to be the vector B. And once we pass these, it's going to create automatically a list of our solutions. So let's actually see how this is going to work. So here I have the same numbers that I have up here. Let's do a second order, and from the second order, if you remember, we have an intercept of 4.563. Here the coefficient of x1 is 2.06 and this one is 2.39. So let's actually see if we're going to get the same numbers here. If I run this, you can see that we got the same exact numbers: 4.56, 2.06, 2.39. It's great. You know now how to develop the code for solving linear algebra systems of equations, but now you can actually make it simple on yourself, and you can actually call inbuilt functions within Python, like for instance the .ln and linalg.solve, and you have basically taken this entire section of code here and you reduced it to one line of code, which is practically what's really happening within here. It's just this is defined inside of Python in the backend. So this is a great way of actually you simplifying a lot of your code. Just take advantage of these inbuilt functions. So just wanted to show you this for this lesson. In the next lesson, we're going to go into how to perfect more complicated functions like power functions, exponential functions, and growth saturation functions. So that's going to be it for this lesson, and thank you, and I will see you in the next lecture.